Welcome back to Clean Code and Programming Principles, the Ultimate Beginner's Guide. In this video, we're going to cover the principle of separation of concerns. So what is separation of concerns? It means to organize your code well and for your code to have specific and sensible responsibilities. So for example, if you have a class called Circle, you have a pretty good idea of what that class is supposed to do. You expect functionality relevant to circles in there, such as some method for getting the area, a method for getting the circumference, maybe some other circle math stuff, and perhaps some properties like the diameter and the radius and things like that. But you do not expect some functionality in there about printing something to the screen or sending an email or anything else like that. If there was something like that in there, that would be unexpected. And not only that, but you wouldn't know where to find it. Like if that's what you were looking for, you didn't know it was in Circle and things like that. Another example is, say, for example, you had a module named math, like you do in the JavaScript programming language. You have an object named math. And anyway, you would expect that math module or whatever it was to have math-related stuff in there. Like again, it might have a function for calculating the power of something, for calculating the factorial of something, and things like that. Once again, you wouldn't expect that to be something about printing to the screen or sending an email or formatting some data and things like that. So that's what we want. That's the basics of separation of concerns. We want code organized well, and we want responsibilities to be obvious and relevant. We don't want things to do unrelated stuff. Another relevant point about separation of concerns is that units should be small. And units are basically any kind of code. It includes functions, methods, classes, modules, and even packages or libraries. We want units to be small and to do specific things. So as an example, instead of having a massive class called shape, which we'll see in the next slide, and that shape handles a lot of different shapes, circles, rectangles, triangles, and whatnot, we don't want that. What we would prefer is to have a separate class for its shape. So for example, we would have a class for circle, a class for rectangle, and so on. That's generally what we want in programming. We want small units and we want concerns separated. So for example, here is what a class for shape might look like. And just look at that code. That is not simple, okay? And currently this is handling 3 shapes. And it's got one method and a constructor, okay? So you just imagine how much worse it would be if we added more methods and if we added more shapes. It's already quite a disaster and it would be a lot worse, okay? And in comparison, here's what it would look like if we had classes for the individual shapes instead. So look at this slide. And I'm gonna change the previous slide again. And look at it compared to that. So if we look at class circle for a second, it's super simple, right? It's got a couple of lines of code and it's super simple. And if you want to change anything in there, like you can change it easily. If you want to change anything in the previous slide relating to circle, you're gonna have a lot more work to do. So this is generally what we want. We want concerns separated like this. So this is another example, a send data function, which I made up. This isn't real code, but I hope you get the idea. This is something like what you might find in a real code base, even though this code wouldn't actually run because it's fake. But anyway, let's see what it does briefly. So what the whole function does is it formats some data, validates it, and then sends a network request with the data or something. Yeah, so that's what it does. And we have the formatting at the top. It's a little block at the top there. And we have the data validation in the if statement. And then we send a network request, or if the data didn't validate, we send an error, which just has a comment there. And this is what we might do to improve that code slightly. This, in my opinion, is slightly improved. But now, please note that this example versus the previous example, this is quite a subtle improvement. In fact, you might very well think that this isn't actually an improvement. We've made the code longer and all that stuff. So improvement or not, it doesn't make a lot of difference, okay? But the SAPE example was a significant difference. So that's fine. Not all of the code that you separate may end up making a significant difference. This is where you're going to have to use your own judgment for whether to do things like that. Regardless, this code I believe is slightly better, and the changes we made are fairly simple. Overall, we just extracted some of the functions from the send data function outside of it. So instead of having the formatting of the data in line, we now have a function called format instead. Instead of validating the data in send data in line, we created a function called isValid, which validates the data, and things like that. So fairly simple changes. Okay, so the reason why we do this is because smaller units like this now, these units are now smaller in this example because the functions are smaller. Smaller units come with a lot of advantages, and here they are. So the advantages of small units are better code organization, simplicity and understandability, easier changes, easier to test, and easier to reuse. And we'll go over each one of these in detail. So starting with better code organization. So if we consider our examples again, in the SAPE example, finding the functionality relating to just circle or to just rectangle is a lot more difficult than when we had those individual classes. So let me show you the slides again. So here is the SAPE class again. So we can find circle, but there is a ton of code and it's very messy. And for every method we want relating to circle, we have to jump around through a lot of code. And here on this slide is the code for circle, and you can find it immediately, and the organization is better. So if someone in the code base wants to find functionality for circle, this is obviously the better way to do it. Then we have the send data example. And as we said, this is a lot more subtle, but I still think that finding the functionality in here is slightly better. So here is the code. And notice that, for example, if you want to find the functionality for formatting the data, it's right here in a function called format. And all of that functionality is there as well. So the function is labeled format, so you can find it immediately. And the stuff it does is in there as well. So again, you can find it immediately. But if we consider the different version, I'll change the slide now. So in here, the formatting functionality is at the top. So this isn't so bad actually, because in this code, it's a neat block at the top. But you can imagine in real code, it might not be a neat block at the very top. You might have a bit of formatting functionality on line 5, then you might have some different code after that, and then you have a bit more functionality for formatting on line 12. So the code is jumping around and intertwined and stuff, and that's why in this example it's not as bad, but in real code it could be. But again, in the good example, it's all there. No matter what you do, you can find it immediately. And exactly the same thing applies for isValid and send error and so on. And not only that, but in the bad code example, first, say you were looking for the isValid functionality. First of all, you have to read through the entire function, and then you somehow have to realize that the validation functionality is in the if statement. And you may not realize that. You know, if you don't know the code, and if you don't know what the validation functionality looks like, you might not realize, oh, there are the lines I need. Especially, you know, if you come back a year later or if you're new. But when you're writing the code for the first time, you know what the validation functionality is. So back to the good slide again. If you put it in a function named isValid, then everyone will always know that this is the validation functionality. So that's what I mean when I say the code organization is a little bit better in this case as well. So that's what small units do for us, small units with a good name. Back to the points. So next we have simplicity and understandability. So again, if we consider the code, here is the bad SAPE example. And this is awful. This is not simple, and it's difficult to understand because you have switches, you have if statements everywhere, you have different methods, you have to jump around. It's not nice. In comparison, this is super simple. This is like as simple as it can be. You have the circle, you have some methods for it, you have a, you know, I don't need to go into too much. This is just super simple. Back to send data. So here's the good example. And if you look at this, if you look at the same data function, it kind of reads like English. So it says constant formatted data equals the result of format data. It's like English. If the data is valid, send a network request. Otherwise, send the error. And then, yeah, so that's the main function, send data. In comparison, if we switch to the worse version, here, to understand what send data does, you have to read through every function. And there are no labels. Like when you're formatting the data, okay, you're lucky there. It has the name formatted data for the variable, but it's like functionality afterwards. It doesn't tell you what it does. Same thing for the validation of the data. It has some lines either. It doesn't tell you this validates the data. So first of all, it's harder to understand because it doesn't have good labels for what it does. And secondly, there is more code to read before you can understand it and to digest. But in the good version, you can read this line, send data like English, and you don't need to look at the other functionality because the names tell you what it does, right? That's one of the points we saw in the previous principle. Keep it simple, right? And not just that. The functions we extracted like format, is valid, and send error are also easier to understand because they have a nice label telling you what they do, and the label helps you in understanding the code. Yeah, so I'm just ranting at this point, but I hope you get the idea. This is slightly nicer for a newcomer to look at and understand faster. The next point, and this is one of the more important ones, is easier changes. So this is actually one of the requirements of software that we have, and it's really important. So again, consider the shape class, the bad example that we had for shape. If you want to change the functionality relating to circles in this class, what do you have to do? Well, first of all, you have to jump around different methods. Secondly, you've got to find the correct if statement, put your change in there. It's doable, yeah, but let's just say that it's a lot harder than changing this. Here, if you want to change circle, easy. Here are the circle lines. You want to change, you want to add an additional method, easy. You want to change, do you have a bug in get area? You want to change that? It's one line, change it, that's fine. In the bad example, it's much more difficult for you to change that. And not only that, because there is irrelevant code in here, at least from the circle's point of view, surrounding the circle functionality. If you accidentally change, say, for example, the code for square instead of for circle, and it's not difficult to see how someone might make that mistake, you now have a bug. But in this class, you can't change the code for square because it's not there. So changes are easier because we've extracted that functionality somewhere else. There is no other functionality to be found in here, so you can't break other functionality. And finally, in the send data example, same thing applies here in this good example. If you want to change how the validation functionality works here, it's a lot easier to do it than the other example because you can see right away the isValid function, so you know the functionality is there, and you can change the thing. There is no irrelevant code nearby. Whereas in the bad example, the functionality is in that if statement. So first of all, as we said, you might not realize where it is. And for whatever reason, if you change some of the other code in there, you don't just change the code in the if statement, you now have a bug. So yeah, this is fairly simple code. It's unlikely you'll do that, but someone might. And if you're tired, you might do it that day, and so on. So changes are easier if you extract those units. And next, we have easier to test. So this should be fairly obvious, I think, if you're familiar with testing. But if you have a unit that does less stuff, it's generally easier to test than if it does more stuff. So in this case, this applies both to the shape classes, the individual shape classes are easier to test, and also to the send data functionality if you want to unit test the individual functionalities in there, like the isValid function or the format function. And finally, we have the point that smaller units are easier to reuse. And that's because imagine if a unit does one thing and one thing only, then you can reuse it immediately anytime you need that one thing. But if a unit does 10 things or even 2 things, it cannot be reused unless you need all of those things and in that order. So that is why smaller units are better for this reason. So for example, again, if we look at the send data example, if you need to reuse the format function or the isValid function anywhere else in your code base, then you can. But if they were in send data, you wouldn't be able to reuse those. Okay, so hopefully you now have a better idea for why smaller units are beneficial. So you know why separation of concerns is good. Now let's see how to apply separation of concerns. And actually the answer to that is quite simple. You apply separation of concerns purely by extracting functionality. So just like we did in the shape example, we took all the code that was relevant to circles and we extracted it into its own class called circle. And the same, of course, for the other shapes. And in the send data example, we took the different functionality, like for formatting data and for validating the data, and we just extracted it into its own functions. So nothing too special here, just extract the functionality. So the key question is, when should you apply separation of concerns? Or rather, when should you extract stuff more? And there are two things I would say about this. First of all, you might already be aware of this if you've encountered this before, but the rule of thumb is to have units that do only one thing. So generally that's known as a single responsibility principle. In addition to that, I would say you should extract functionality whenever you want more of the benefits of smaller units. So let's go into them a little bit more. First of all, what's a unit that only does one thing? So that's very difficult to describe because the truth is it depends on context. Okay, so for the sake of example, consider a function named double array. And of course, what it does is it takes an array and it doubles every element inside the array, and then it returns the result, probably a new array rather than modifying in place. But regardless, take that example. Now, how many things does that function do? You could truthfully say that it does one thing. It doubles the elements of an array, and it returns it. That's like one thing. Or you could instead say it does 5 things actually. It creates a new array, it has a for loop to iterate through the previous array, it grabs every element, it doubles every element, pushes it to the array, and then returns the result. That's like 5 things. And again, you would be right. It's true, it does those things. Or you could go even further and you could say, actually, it does like 100 things or 1,000 things. And again, you would be right. Because if you go all the way down to memory allocation and freeing up memory and like having the CPU do addition operators or whatever it is, yeah, you could easily say it does 1,000 things. So when you say units that only do one thing, you have to use common sense and your own judgment, because depending on how far you break it down, they might do one thing or they could do 3,000 things, okay? So just use your own judgment and your own opinion and common sense. And consider instead, does this unit feel like it's doing one thing? Is it doing something small? And could it be broken down further, reasonably? So yeah, those kinds of things. But anyway, let's move on to some other guidelines you can use to help you with this. And those are, consider, does the code feel large and complicated? Can you keep extracting functionality from it reasonably? What reasons does it have to change, and who, meaning which role in the company, may want to change that code? So those are things that I like to think about when I'm working to help me. So let's examine those one by one, starting by, does the code feel large and complicated? So this is a personal thing, and again, you have to use your own judgment. You're the professional here. Very simply, if some code is long and difficult to understand, try extracting a few units from it. You know, just like we saw in the send data example, it makes the code read like English. It makes the code shorter for particular functions. So it could be a good thing. It could make the particular code in question simpler and easier to understand. So just ask yourself that. Next, can you keep extracting? Can you reasonably extract more functions from that code, just like we did in the send data example, right? I don't think it would make more sense to extract even more functionality, but think of it in your own code. In the code you have, can you extract more functionality and have your code still reasonable to use? So if you can, then try extracting more and see if it's better. Okay, next. What reasons does the code have to change? So basically, different reasons to change indicate separate concerns, which, as we've already examined in this video, means that you should probably extract them for the benefits that small units provide, okay? So let's consider the examples we had in this video. The shape example, what reasons does it have to change? And it's got quite a few. Anytime any of the individual shapes need to change, for whatever reason, shape also changes. So if you had 10 shapes, then that's 10 reasons to change anytime that shape needs changing. And additionally, if you want to add another shape, a new shape, again, that class needs to change. However, after we extracted the shapes into separate classes, then those new separate classes only have one reason to change, right? So if circle needs to change, then circle needs to change. But that doesn't also mean that rectangles are going to change, because we've separated the reasons that everything has to change. Does that make sense? And also in the send data example, now that one's more subtle maybe, but here are some of the reasons that send data has to change. So the formatting of the data may need to change, the validation of the data may need to change, the data in the error request may need to change, the endpoint, which means the URL of the error request, may need to change, and same thing with a normal valid send data request, and so on. So it has a lot of reasons to change. And as we saw, making changes easy is one of our core requirements of software. So again, we want to extract that functionality with different reasons to change so that when we do need to change in the future, it's easier to change. And of course, all the other benefits that smaller units provide. And finally, we have who, meaning which role in the company may want to change this code. So this is another flavor of the previous question of what reasons does this code have to change? This is the same question worded a bit differently, but it still tries to identify the same concerns that will need to be separated. So for example, in the send data example that we had, tech administrators may want to change something about the URL endpoints of the requests or the bodies of the requests. So again, that shows you that that's a concern you might want to separate. Accountants may want to change the data validation in the future, who knows? And the product owner who uses the submitted data to generate reports could want the data formatted differently in the future, and whatever else. I'm just making this up, but I hope you get the idea. So that's basically it for this principle, but a final word on this is to remind you to be pragmatic. So whenever you do anything in software, remember to use your judgment and do what's best for your project. And don't take these principles so far to the extreme that they actually make your code worse. For example, having small units is good, right? Smaller functions are generally better and nicer to work with. But you probably don't want to go extracting so far that your entire code base is made up of 1-line or 2-line functions. Because you probably could do that, but it wouldn't be easier to work with. It would be horrible to work with. I hope you can imagine that, you know? So yeah, use your judgment to be pragmatic and don't do that, you know? And next, you don't necessarily need to separate all possible concerns that could ever exist in your code base. So when you ask yourself, what reasons does this code have to change? Well, you might come up with 20 reasons. You don't need to separate all those 20 things into functions. You could do if you wanted to, but you don't have to, because realistically, out of those 20 reasons, or let's call it 100 reasons for different modules in your code base, only like 5 things will change, not 100. You know what I mean? That's like the Yagni principle, a different principle in programming which stands for you ain't gonna need it. So you could go extracting everything, but it would probably be a waste of time because the things you extract won't change. And again, you don't want 1 or 2-line functions everywhere. So what should you do instead? Instead, be pragmatic and use your judgment about what are the important things to extract. What are the important things that are likely to change and that if I extract will make the code better and easier to work with. So that should be your goal, right? Your goal should be to write good code. These principles are guidelines. Don't apply them so hard that they destroy your code, okay? And some questions you may want to ask yourself are, what's the likelihood that this particular thing will need to change in the future? And is it likely or is it not likely? And further, if it needs to change in the future, what kind of impact will it have? Will it be a disaster? In which case, maybe you want to extract it now just in case, or will it be not a big deal? In which case, just leave it. You know what I mean? And a final note on this, if you're still a beginner with separation of concerns, then consider extracting a bit more than you might need to. Consider taking this principle a bit more to the extreme than not taking it far enough. And the reason for this is so, one, you can get practice using the principle, but two, so you can experience what it's like to extract too far. And that experience will help you. And anyway, that's it. That was a very long video, but I hope the concepts that we spoke about make sense, and I hope they help you over time as you continue programming. So anyway, that's it for the video. If you liked the video, then please click the like button. And if you want to be notified of the next videos in this series as they're uploaded, then please subscribe. It really helps the channel when you do those things. And if you have any comments or even counter arguments, then please leave a comment in the comments box below. All right, thanks very much and see you on the next one.